Hello, mentors. Welcome to Meeting 3 Crazy Games. So this is October 19. And in this video, we'll just look at part 1, which is design your game. So work in teams to design our dream sport or competition and talk about the math that we see. So let's dive into the details of this part 1, which is, biggest part of the meeting. It's 50 minutes or so. And so, as we said, students will explore their own preference in sports, competitions, hobbies, crafts, you name it. So we may have students that are not much into sports, and you have to give other ways that they can, create a competition or things they like. If they like sports, that's great, and we'll see an example to that. And yeah, that's the main goal. Non-mathematically, share different things about their worlds, what they do in their free time. So in a sense, this all design your game activity is kind of like an excuse to get into students' interests because they'll be designing a game. So they really, they'll start with things they like. In terms of the math, the first students will meet a game called football, which is a mix between football or soccer and basketball. And then they'll see some math, and that will serve as a model. And after that, they'll create a project, a brand new game or competition with creative scoring rules and other mathematical features. So what do you do as a mentor? Well, yeah, you're not giving any problems or like fixed problems. There's no much student workbook this time. So your goal is more to bring the math up front through questions, lots of questions that make students think and revise their game. So you're constantly monitoring, kind of like an advisor, they can ask you things or you can comment on things to guide them a little bit, push them. So we'll see more details on that. Break down three parts for this part. So first, introduction, we talk about football. Then the meaty part, the design. So work about half an hour in small groups of 2 to 4 students. You could do even bigger groups if they work really well together. So I'll leave you the details to your mentoring team, but otherwise 2 to 4 should be recommended. And then sharing and voting. So in 10 minutes, students or groups will share all the creations, and then you guys will all vote for the best one, the most creative or most fun, most inclusive. So you can have all sorts of criteria there. But it's just a closure, like an effective closure, so that all students can actually know what their team, their peers did. So this is the introduction, and let's go to the student manual. So we start with this, a mix of football and basketball. So this meeting, we don't start with general questions or reflections as previous meetings, say about brain disorders, right? Or even in the interviews, more general questions, but we dive right into a game. So the purpose from this design point of view is that they're kind of surprised or they're kind of attracted to some crazy thing, right? And it will serve as a model for what follows. So this mix, here are the rules. A goal is worth 4 points. A basket from inside the area is worth 6 points. So 4 points, 6 points. And then like a 3-pointer, a basket from far away is worth 8 points. So it would be called an 8-pointer. And also, you don't give any more details, but you just say kind of, well, it sounds weird. There's many things that we don't know about this game. So what else would you like to know about this game? You would ask. And then after some discussion, you would dive more into more close mathematical things. But let's first look at this question. What else would you like to know about this game? And in the teaching manual or the pear deck, you have some answers, sample responses from students. Is the game played on grass or in pavement? What kind of ball is used? How was scoring decided? Is it fair? Does it make sense? Because yeah, it's crazy, right? Look at these 4 points, 6 points, and then 8 points. Who decided that, right? What was the criteria? So there's some math into it that you hope students will ask questions about it. How many people play? Is there a goalkeeper? How long a game should be? And so all these questions is really important that you model those. So you You can ask some of them, not all of them, or maybe rephrase some that students ask. So it's kind of a discussion. The quality of these questions, so this really good focus here, because this will help during the next activity where students actually indirectly answer these questions when they're building their designs, when they're doing the game. So you're really setting the tone for what follows in the quality of these questions. And quality means how much math is really there, and how much depth is there. You don't want shallow questions like what's the color of the uniform. I mean, those are fine, but you really want to focus more on the structure of the game, right, and mathematical things about the game. So this is very open-ended right here. But then there's a model. So going back to this game, now we would complete the table. So this table is, it's partial because it just says, okay, how many goals or baskets from near or baskets from far away Mexico and Puerto Rico scored. And there's several ways to complete this table. So, I mean, this table is complete in the sense that there's no more cells visible. So students should brainstorm on how they're going to extend the table, and there's several ways. So let me show you some answers that you can look more detail after this video. One way would be to do this row about points, and then do the total to see that Mexico won by 10. And there's other creative ways that is kind of a canceling out table where you have a lot of zeros here, which is the logic is, okay, goals, Mexico did 10, Puerto Rico did 4. So if we just remove 4 to each, we will have the same scoring difference at the end. So 10-4 is kind of equivalent to 6-0, right? There's an equivalence there. So same you would do for baskets from near. Instead of a 12-9, you would just say Mexico won by 3 in that category, and then Puerto Rico won 4-0 in terms of difference. Then you would just have simpler numbers, and you would total the difference to see that Mexico won by 42. Sorry, by 10, because the difference, I mean, was 42 for Mexico and 32 for Puerto Rico. So it's a 10 difference. Anyways, you could discuss a little bit about this, and then there's a little more interesting problem to close this football, which says, from analytics, it's discovered that the US team had a 15% conversion rate on goals, 10% on near baskets, and 7% on faraway baskets. If you were the coach, what would be your strategy? So of course, there's a discussion about the definition. What does it mean to talk about the conversion rate? And so it's important to to support your students in that. We don't offer the definition in the workbook, and the main reason is some students may already know it, so they will have the voice instead of we just putting the definition there and removing the chance of giving the voice. Worst case, nobody's really sure. Well, you start building the the concept with questions like, have you seen this in other sports, maybe, or putting another analogy, etc. And this is a nice game, and a nice problem in which the answer, well, yeah, we don't have it yet here, but the idea is that let me go back to the idea is that you have to mix these numbers here, 15, 10, and 7%, with these words, right? So, I mean, the most likely thing that the US team can do is score a goal, right? Because 15% is larger than 10 or 7. But scoring a goal is only worth 4 points. So what's gonna be the return of this investment, right? If I shoot 100 or do 100 attempts, right? Only 15 will be successful, and 15 times 4 will be 60. So I should get 60 points. On the other hand, if I do, for example, this 10% conversion rate on near baskets, you would try to do the same. So it's gonna be a problem in the paradigm. So I'll leave the details for you guys to try to solve this interesting problem. So that's football, and you should spend 10 minutes, no more than 15, setting up the stage, trying to do it kind of all together. But yeah, the main purpose is that football becomes just a sample, just a model of what comes. And what comes? Well, let's see. So you're gonna design your game as teams. So first you have this discussion, general discussion. Who are your idols? Anyone in sports, athletics, any other type of competition? This interesting question in your school: who is or are the best at, and then fill in the blanks. So I mean, many funny answers could be there, interesting things. You could say the best at reading, the best at sports, or creating jokes, anything that comes to mind. And your mentors could also say in my family the best at this is that. So another opportunity to get to know your students in an informal way. And sometimes you ask questions that are too general, and then you just get answers of yes, I like very much. So hopefully this who is the best at, I mean, makes students think, and then when they bring some answer up front, you actually have a chance to discover things that you didn't really know about your students. So many different angles, many different strategies to get to know your students more. So the next Olympic Games need a new crazy competition, and they hire you guys to create it. They pay you, and you need to design things like how the game works in general, equipment, number of people, dimensions of the field, if there's any field, the scoring is going to be a main important mathematical topic, the scoring, the rules. So there's going to be many mathematical things, but probably the most powerful will be the scoring. So like in this football game, the time rules and any other math things of the game. So we don't close the door and just say do the rules, but just think of many things and just try to get some math out of it. Think individually first to get some ideas, very important step, and then you make teams of 2 to 3 to create your game. And so they're gonna work about half an hour or so, or 25 minutes, just creating this game. And then after that, the committee, so we're going to decide together which competition is going to be chosen by voting. And chosen means that you're going to hopefully present to the whole school. So it's just kind of you know, it's like if they were countries, right? And they were creating this, you would have in your table maybe 2 or 3 candidates, but you would just choose one. And then maybe that will be presented or not, but that'll be kind of your submission to your classroom leaders. Let's keep in mind, will the sport be easy for almost all countries to practice? Will both men and women be interested in playing? Older people will be fun to watch? Is it really a new sport? Or is it maybe too close to another sport? So here we have some equity, social justice, culturally impact in the sense of the game. So this should be valued if it's easy for almost all people or countries, and also if it's fair for both men and women, or interesting older people also. So you're just bringing this to the table. That is the game that you're creating fair. Is it balanced? Is it sensitive from a social point of view, or is it unbalanced or so? So you want to bring that into the discussion. And then, well, after we select it, we can make some small changes. So that's part one. And I think it's a lot of things, but in the same way, it's a lot of things, but also it's like many, different possibilities, right? You may be wondering, what do I do? Because there's no games for them to analyze. They're going to be creating the game. So it's kind of shifted, right? Because now you are following the students and not the other way around. So it's going to be challenging. It's going to be challenging from the point of view of teaching. So we have some supports for you in the manual, and let me show you. Of course, you may enlarge this list, but these are the types of questions during monitoring. So this list has sample questions or prompts to ask during the game creation. It will depend on your students' need. So we're anticipating these 3 big problems that students will surely have. So because it's going to be also new for them. I mean, it's going to be hopefully exciting, but some may be also kind of confused or, kind of surprised. Aren't we solving just math problems like we did before? Okay, so three categories are if students are uninspired, right? They're kind of stuck and they don't know what to do. The second category is if students are not focusing on math things, so they're making excellent projects, but you don't seem to, to find any math at all. Or if the math seems is there, it exists, but seems kind of simple or not that interesting or challenging. So it needs to kind of be, boosted a little bit by you guys. So if students are uninspired, you could ask, what is something that you like that you think you can turn it into a competition? Can you mix two different things that you like, create kind of a freaky creature? So that's gonna be like a creative way of, continuing. And then let's maybe first decide something broad, something general. Are we doing arts, cooking, a sport? Are we doing music? Anything? And then narrow it down. So those are three kind of brainstorming ways so that students can move on and decide. If students are not focusing on math, you could ask which numbers or other mathematical things, shapes, or maybe some graphs, maybe fractions, anything that comes to mind, even stats, would people see if they're watching your game? So I'm watching your game. Okay, you created a game. And what kind of questions could I ask, or kind of what's the math that I would see? So this is very, very simple questions, very general, but can lead to many brainstorming. Let's write a list. And then you can be more specific and ask questions about the time, the dimensions of the field, the combination of players that can play. So you could have counting problems there, very interesting. The maximum possible scoring versus the realistic scoring, basic winning strategies, like in this football, when we were talking about the US coach. Let me go back here to make the connection. And then, yeah, here, sorry, you were asking if you were the coach, what are you gonna do? Are you gonna shoot goals or try baskets or far away or doesn't matter? So you could brainstorm those kind of questions on the spot, and that's gonna be the challenge, right? Because you don't know the game, so you're not able to plan. You have to really improvise and on the spot create math problems. Sounds fun, right? So that's for that. And finally, let me go back to these supports. Sorry, here. If the math seems simple and you want to make it more powerful, you could perhaps suggest changing just a tiny part of the rules to something that's more interesting, more surprising, a little more complicated, kind of crazy, that doesn't make much sense, hopefully. And then the math kind of starts flowing. So hopefully, because doing math is kind of being surprised by things you don't know and then making sense of it, step by step, right? So that's kind of the thing that we would do. You could also compare the game to similar game using math. You have this freaky creation from students. They design this weird game. You find some game that is somehow close, and then you just focus on what's the math different and what's the math the same between those two competitions or games. And that can be a way to bring more complicated things, math things that maybe students weren't paying attention to, right? And that can, lead to changes in the game. So those are the supports that we have. And finally, for sharing and voting, so each small group presents their game, make it pretty quick, 2-3 minutes or so, and then students will vote for their favorite game. You can vote for your own game if you're a student, which makes it creates an interesting ethical dilemma. Should I vote for my creations? And some students may actually do it, and some students may actually don't do it, even if they think their game is the best. And it's okay to talk about it. It's actually recommended, to talk about it, because this brings interesting things about, ethics in voting, right? Are you supposed to vote for your own creation? Well, yeah, I mean, why not? But maybe it's unfair. So, it brings interesting discussion about bias and about, fairness. So here's an example. I'll let you guys, read that on your own time. But you can create your own voting systems. On worst case scenario, if you don't have much time, it's perfectly fine to just go for a simple vote or just pick one team, whoever wants to really present right, in the next part, and that team will represent the table. So your job is to pick one of the 2 or 3, games that students will have. Closing remarks for this part: as a mentor, you should be kind of an advisor, but a very close one, almost being part of the team. So when you use the language, you could say our game, our creation, or you could say I want to do this instead of you guys should do your game, blah blah blah. Because when you establish this distance, then the relation becomes more vertical, right? More hierarchy. So you're the teacher and you're judging. It's very subtle. Whereas if you actually, talk in a way that it's your game and you're part of all the games, then it's more like a partnership and it's collaborating together and they can ask you questions, right? So you create a very different dynamic. And this is meeting 3 already. So the first 2 meetings you've established, somewhat strong relation. So you can dive even more into that partnership. So that's pretty much the game. And Per Deck has, this again, write your own enrichment goal that hopefully you can try to see, okay, what am I going to concentrate on for celebrating or empowering or caring, etc. So that's part 1, and hopefully you guys have fun in this game. The last thing is hopefully you have you create before the meeting at least 2 or even 3 games, like sample ones. And that's really the key to anticipating this part if students are not focusing on math. Because if you do your homework and really prepare creating your 2 or 3 games with your co-mentors, then you will easily or more easily transfer to when you're teaching to actually come up with questions, mathematical questions, even if it's a different game, right? Whereas if you didn't do your games, it's going to be really challenging to see a game from another, student or person and really come up with, with math proposals on the spot. So really focus on creating games before. Of course, during Monday coaching, we'll be also doing that. But the more you can do, preparing with your commenters, you'll be more prepared. Okay, guys, thank you so much and hope you really enjoy the meeting. Goodbye.